Hello guys, in this video we will learn about functions and its transformation. Okay, so let's move ahead. Let's consider a function. So first of all, what is a function? A function is like a box which processes the input given to it and returns a definite output for every input. So every input has a definite particular output, and one input do not have more than one output. Okay, so that is what a function is. Now let's take an example of a function. Fx is equals to x squared, where x is the input given to a function and fx is the output that will come out of the function whenever x is given as input. Now we want to evaluate the function for different values starting from -3 to 3. So the input that we are giving to it is -3 to 3. Okay, and let's try to evaluate it. So to find the value of a function based on an input, we have to put that particular value of the input inside the function. So first, for the first number, x is equals to -3. So everything that is x in the equation of the function, we replace it by -3. So we replace x by -3, -3 brackets and a square on the top. So f minus 3, f with the input of -3 becomes 9. And let's go on and let's find for -2. So it will also become 4 because minus minus plus 2 2s are 4. Let's find for the other values. And we see that we have for 1 squared is 1. For 2 we have 4, and for 3 again we have a 9 here. Okay, now let's try to plot this function here. Let's try to plot fx over here. And now let's try to plot it. So at -3x, this is our x-axis, and this is our y-axis, which is our output of the function. So when x was -3, the output was 9, so somewhere here. And when x was -2, we can see that the output was 4. So when it was -2, output was 4. When it was 1, the output was 1. So 1, the output was 1 somewhere here, and when it was 0, the output was 0. When it was 1 again, the output was 1. When it was 2, the output was 4. And when it was 3, the output was 9. So now we connect all the dots and then we get a function over here. Now, how does a plot help us? It should be more of a curve. It's obviously different when I'm drawing it on the computer. But whenever you draw a function, it actually shows you when you connect the dots in between, it gives you a very close approximation of other values of the function. So if you want to find -1.5 is equals to what, you can just match the graph and you can find the value. This is not very accurate because the scale is not accurate here, but when you plot it on a graph paper, then it gives you a very definite value. Okay, let's move on and try to evaluate a different function here. Now let's try to see if we have fx here, which was fx is equals to x squared. Now what will fx plus 2 be equal to? And this definitely, if we are adding +2 here in fx, we will also add on the whatever you add on the left hand side, you add that on the right hand side as well. So fx plus 2 is actually equals to x squared for plus 2, right? We'll call this new function as g of x, where gx is equals to fx plus 2. And now let's try to plot this function. So gx is equals to x squared plus 2. So now when we check from the range of minus 3 to 3, we see that for x is equals to minus 3 and 3, what will our fx be? Function g of x. So g of x is x squared plus 2. So let's put minus 3 in here. Minus 3 squared plus 2, which is 9, plus 2, which is equal to 11. And let's go on for minus 2 squared plus 2, which will be equal to 6. For 1 it will be 3, for 0 it will be 2, for 1 again it will be 3, for 2 it will be 6, and for 3 it will be 11. So now let's try to plot gx. Now let's plot our graph. So for minus 3 as the input x, the gx value came out to be 11. So somewhere here. Then we have for minus 2, 6. Then for minus 1, we have 3. And for 0, we have 2. And for again 1, we have 3. For 2, we have 6. And for 3, we have 11. So let's connect the dots here. Okay, so we connect the dots here. And now let's see the graph of, let's compare the graph of f of x and g of x. So what is the difference between the graph of f of x and g of x? That the whole graph of f of x is shifted 2 notches up, 2 units up, right? The point of coincident with the y of x in the f of x graph is 0. Point of coincidence, while for g of x the point of coincidence is 2, right? So now there is a transformation of plus 2 units up from f of x to g of x, and it is shifted upwards. Now let's try to infer something from this. So what we have learned is when we add plus 2 to the whole of f of x, the graph shifts upwards. Now from this, if we have h of x, which is f of x minus 3, then what will happen? So from this if inference, if we have f of x plus 2, this graph shifts upwards. Now if we subtract something from f of x, it makes sense that the graph would shift downwards. This is known as transformation along the output of the function. So we see that whenever we change something to the output of the function, fx is the output of the function. If we change something to the output of the function, the graph moves up or down, right? By adding or subtracting something out of the function, right?
So that's it for this video. In this video, we saw the transformation on the output of the function when we do addition and subtraction to the output of the function. In the next parts, we will go about doing multiplication and division on the output of the function, as well as changing the input of the function and seeing its transformation on the output. And further on, we will do more problem solving based on the transformations given. So stay tuned and go for the next part to look at the complete transformation of functions, and subscribe to the channel and like and share to view more such content.